lecture series for manufacturing technology, second unit, third lecture 49, machines and milling machine tools. Okay, some of the machines also for perform discuss for last lecture for the suppose that indexing of milling machine and the compounding of milling machines and angular of milling machines. Okay, some of the milling machines are discussed for, and compounding milling machines is the use for the 40 teeth of gear and warm soft and the warm gear used for these machines and for the and perform to the manufacturing operation of these machines and the generate to the continuous operations and the sum of use for and solve solutions for the sum of the numerical problems of the end compounding indexing of the milling machines and the compounding of milling machines, some use for the cutters and other for the dividing of the heads of dividing of head. Okay, these are the three main part of the milling machines and solve this based on the numerical values and solve this the in the rotations of the hose and the plates are used second plate and first plates from based on the shall solve is the numerical problems. Okay, and some of the this is video is very important for discuss for against for some of the formula and drive for the formula and solution for the sum of numerical problems and indexings of the milling machines. Okay, the milling times and power estimation, some of the this is the milling times. Okay, one is the this start for the manufacturing operation of the milling machines operations and for discuss for an analysis of the milling times. Okay, cut for the metals is the this is performed to the milling cutters and this operation is known as the milling mailing operation and the acting for the time in this operations is known as the mailing times and the use for the all the most important for the generative the manufacturing operation in acting for the main functions of the power. Okay, power estimation of the power required for the and operation start and end of the mailing operations and for most important for required for the powers. Okay, the powers find out the powers. Okay, and use for formula estimating for the other for time estimations. Okay, mailing time estimation and mailing power estimation on mailing tabular for the sortings. Okay, sorting of the other problems and discuss for the sum of important for the factors and derive for the formula and analysis of the mailing cutters and mailing operation and okay, and milling times and power estimation, some of the values are the depend upon the milling cutters. Okay, milling time estimation, so suppose that the typical process and parameters used for the sum of important and standard parameters of the assume for these operations and suppose that the the of the soft is also wounded on soft is rotate for the and milling cutters also bounded on the milling shaft. Okay, and the milling operations are given for the sum of standard values used for these operations and some of the assumptions on main function. Okay, and for drive for the formula is suppose that one formula is the most important for this production in operation used for the cutting speed in milling is the speed surface speed of the milling cutters. Thus, for the use for the formula V barabar pi dn upon 1000. Okay, V is the cutting milling cutting speed and D is the diameter of the shaft and diameter of the tool diameter. Okay, and D n is the number of rotations of the shaft. Okay, and with the cutting speed in surface meter per minute and diameter of the milling cutters in mm N is the rotational speed of the milling cutter in rpm. Okay, this is the formula is the most important formula, and use for the value of the diameter of the tools, cutting tools, milling cutter. Okay, and find out the velocity of the milling cutting speed. Okay, and some given for the problems in the one or two values, and find out the third value of the by using this formula. Okay, and some of the this is the v is the velocity cutting speed of the uh, cutting speed of the tools, and okay, and cutting speed on a surface, minute meter per minute. Okay, and the rotational speed of the milling cutter in rpm. The flat surface can be generated by using the slab milling as well as the face milling. Okay, this is a formula used for the flat milling surface and cutting for the flat milling surface, and as well as by using the slab milling. Okay, milling as well as the face milling operation are generated in this, and the functions of the manufacturing operation and use for the in the mechanical industry. Okay, and some of these the this is the formula used for the flat surface can be generated by using of the milling operations. And second is the this formula also used for the side slab milling as well as the face milling operation, and is used for the formula. I find out the value of velocity, speed of the speed of the cutter, and the d is the diameter of the milling cutters in mm, and n is the rotational speed of the milling cutter in rpm. Okay, however each of this operation is different in terms of the actual machining time required. Okay, some of the one job is complete to the this operation for milling operation in the acting for the time. Okay, acting for the time required for the complete for the one job in operations. Okay, and milling time estimations. Suppose that the milling cutter will be to transfers for the actual work piece by use the distance terms as the approach allowances. A is which is given by the approach of distance a, the approaches distance for under root d by 2 का whole square minus capital D upon capital D by 2 minus small d square. Okay, suppose that this is the capital D diameter of the slab milling cutter, and D is the depth of cut of the workpiece. Okay, and this milling cutters will have to transfer to the powers of the acting for the cutting for uh, cutting force required for the perform to the actual workpiece. Okay, actual work distance terms as for the approaches for a is the present for the approaches. Okay, and approach distance a equal to under root d by 2 का whole square minus capital D by 2 minus 2 small d का whole square. Okay, suppose that this is terms for solve, under root 2 से 2 cancel. Okay, d by 2 minus d by 2 equal to आ गया small d is given for the common value, and capital D minus small d. Okay, capital D is the diameter of the slab milling cutter. Okay, slab milling cutter is the large milling cutter, and D is the depth of the cut of the workpiece. Okay, and the the time for the one passes. Okay, the tools is also for rotate. This is the tools. Okay, and tools also for rotate the one the forward direction and backward direction. Suppose that, considering, okay, the one, this is the one part, this is the tools is the uh, travel for distance, okay, tools for travel for distance, and tools is travel for distance for this is point, okay, and other is the other passes for this is the again repeated for the backward directions, okay, and this is the tools also for traveling to the this one pass, okay, one pass is the time required for one passes is the 1 in plus 2 into one distance, and this is one distance and one distance, there are two distance, okay, into approaches, or both are approaches is a approaches a upon af is the feed rate, okay, and z is the number of teeth in the baling cutter, okay, and as is the tools is also rotate for the in rpms, okay, feed per teeth of in mm, okay, and this is the formula is the most important for the use for the estimation of the time required for the milling operations, and f is feed per teeth in mm, okay, a milling times estimation for the question solve, okay, a carbon carbon steel for the C40 C50 steel flat surface of the 100 and equal to the 200 225 mm is to be produced on a horizontal axis of the, this is the milling machines produced for the horizontal axis of milling machines, a high stainless steel slab mills, okay, high stainless steel slab mills of the 100 mm diameter. D is the cutters is the capital D equal to 100 mm, okay, 100 mm and 100 mm, and the and 150 mm width, okay, width is the uh, small d is equal to is the 100 mm, okay, small d, and width of the use for the purpose, the milling cutter is the ted, and z equal to 8 teeth of the cutter use, and 8 teeth, calculate the machining time, assume that the entire stock can be removed in the one depth of the 2 mm, small d equal to 2 mm, okay, depth of the cut of the 2 mm, okay, I for this is the all the value given in this formula, and suppose that this is the this is the capital D of the, this is the use for the capital D is the, okay, capital D in the total diameter, and the tools is also rotate for the in the clockwise directions in rpms, okay, and the this is the center point of the tools is performed to the work starting point of the, okay, this is the tools consider for, and D is the depth, this is the depth of the feed rate of the 2 mm, okay, small d is equal to 2 mm, equal to 2 mm, okay, and 2 mm for the feed rate is given for the f equal to for the z equal to 8 teeth, and the depth of the is entire for the stainless steel for use for 2 mm of the z slime milling operation. A is the approaches, okay, this is the this is the approach distance, this tools is touch for the workpiece, and but did not touch for the tools is this positions, okay, and this is the discover for the approaches is a given, okay, and the solve these problems and use for the formula, okay, and given for the z equal to is a given for the z equal to 10 8 teeth, and d is equal to 100 mm diameters, and the also for use for capital small d equal to, this is the small d equal to 2 mm, okay, and the for the tables cutting speed we were our consider for the tables. Okay, standard value for is considering for the vehicle to 220 meter per minute, and feed rate is the 0.13 mm per t. This is the standard value of this, depend upon the materials. Okay, and and depend on the for find of the approaches a under road small d coastal capital D minus small d. Okay, so 2 in the small d into for 100 minus 2 is 98. Okay, 98 into 2 is equal to, and 14th. Okay, 14 mm. The approaches a equal to 14 mm. Okay, and the spindle speed, this use for the formula is equal to v per hour pi d n upon 1000. Put for the value, find the value of n. N is the, okay, and this is the formula used for v per hour pi into d into n upon 1000. Okay, and the find the value of n. So n equal to v into 1000. Okay, multiplication of the 1000 upon pi into capital D. Okay, putting the values in this formula, find the value of n. N is the 65 reverse revolution per minute. Okay, and this is the spindle speed. And suppose that some of the use for the time, and find out the time estimation machining time. Okay, the machining time is required for the is the and the formula used for the estimating of the times. Okay, this is formula I discuss for the, okay, this is the formula used for the find out the time for in minutes. Okay, and this time for one passes. Okay, this is given for the value on the formula. 1 is equal to, given for on this formula, the 50 mm. 2 is the 2 distance, and a is approaches, and f is z into, okay, and f is z, and okay, this is the formula used for, this is the time passes. Okay, and this is the given value for the l is equal to 150 plus 2 approaches and 2, and find out the value of approaches, or a is 14. Putting for the value of 14th e, and f is the feed rate 0.13 into 8. Z equal to number of teeth is 8, and is the, and also for the capital D is the use for the n is the 65 mm. This is the find the value of n is the 65 revolution per minute. This value putting for the, and find out the value of the machining time, 2.633 minutes. Okay, and find the, this is the situation for face milling operation using a vertical axis milling machines. Okay, suppose and milling operation and required for the some of parameters used for the standard values. Okay, and suppose that this is the workpiece. Okay, this is the workpiece, and this is the 150 mm. Okay, length of the, and feed rate f is the, this is the feed rate of the, v is the width of the workpiece. Okay, and this is the tools also for selecting for the on the bounded on the shaft. The shaft is a vertical position. This is the shaft is rotated for the in the revolution, minute per revolutions. Okay, and this is the teeth of the cutting milling cutters. Okay, this is the teeth is acting for the of the milling cutters. Okay, this teeth is rotate for the is clockwise directions. Okay, clockwise direction, and cutting for cut for the metals. Okay, this is the cut for the metals, or this is surface. Okay, this is the flat surface, or this is flat surface also for face milling. Friends, this is the face of the workpiece of face milling operations. Okay, and also for discuss for some point of this formula. Other these find out the solution for the second milling times estimation. Second the formula used for the solve these questions is surface of the 115 mm width and capital W equal to value of the 115 mm width and 250 mm long. L equal to 250 mm long is to be rough mild with a depth of cut is 6 mm. Okay, depth of a small d is 6 mm by the 16 z equal to 16 teeth used for the tools concerned. The carbide face milling 150 mm in diameters. Okay, capital D equal to 150 mm. Okay, 150 mm, and the work material is alloy steels in the 200 BHN number. Estimate the casting times. Okay, this time for estimate the cutting times. Okay, and solve this value is the from the consider for the sum of value in the standard of the tables used in okay, for the tables cutting speed we equal to 60 per minute. Okay, and this 60 per minute, and if the feed rate is given for the standard value of the in tables of the 0.1 0.15 per teeth. Okay, required the spindle speed n equal to this formula is v equal to pi d n upon 1000. Okay, use this formula. Okay, and find the value of okay, find the value of n. So n equal to v into 1000 upon pi into d. D is the small. Okay, the putting for the value is the solve this value is the n is the 125 revolution per minute. Okay, this value, and since the capital small w is greater than small d by 2. Okay, also for the solve these problems putting for the find out the approaches. Approach is small d under root a equal to small d capital D minus small d. Okay, and putting for the value find out the approaches value. Okay, and as for approaches value is this is the 65 Okay, a is the 65. Find the machining time or milling time. Okay, and this is the L milling time. L into capital L into 2 into L is the capital A upon feed into z into n. N is the spindle speed, and f is the feed rate, and z is the number of teeth used for the. Okay, putting for the value and find out the mailing times is the 1.06 minutes. Okay, and for some of other value approach distance for the face milling. Face milling case is given for the an a d by 2. Okay, face milling and width of the d is the d by 2 up to d. Okay, and small d equal to d by 2. Okay, d is the very short length. Okay, and the face milling, this is the condition for use for this. Okay, and a is approaches for this operations. A equal to under root d width of the v under root v is width into capital D minus v w. The put for the v the width of the cut. Okay, where the okay, this is the equations is the very important. Okay, this is the for the is very important terms used in this uh, formula. And the power estimation of the suppose that use for the sum of formula use for the similar to the turning milling power can be calculated based on the numerical revolutions that have been developed, and this is the machinery for some of the scientists drive for this formula is the empiricals, okay, calculate based on the empirical relations. This is the empirical relations of the this is the formula is known as empirical relations formula, okay. The C for machineries handbooks, okay, this is the formula used for in handbook directly for drive for the formula in details inform the informations related to the calculations of the sum of standard parameters and sum of functions used. It is assumed that for the milling power, okay, this is the milling power is the proportional to the material removal rate, okay. The power milling power is the P equal directly proportional to M meter removal rate, okay, M meter removal rate, okay, MR. This is the directly depend the material removal rate. Q is the milling is given for the is the q is this is the material removal rate is this is the q value is okay, this is the q value, and q equal to small fd and is wd upon 60,000 centimeter cube per second, okay. This is the power of the and some of the standard values for use in this formula. A small AFM is the feed rate in per minute, okay, and F is asked for FZN, okay, F equal to feed rate, and Z is the number of teeth required for the tools, and N is the number of rotations of the workpiece, okay. Small v is the width of the cut in okay, we cut in and small d is the depth of cut in okay, and F is the feed rate in feed rate in teeth, the tooth as the normally given in the cutting tools, okay, and Z is the number of teeth in the milling cutters. Small z is equal to number of teeth in required for the cutter, and the rotational speed of the spindle in rpm, okay. And this is the formula is very standard of the sum of standard parameters used for the af and width of the turns, and d is the depth of the cut in and f the feed rate in teeth and normal given for the cutting tables, and z is number of teeth in the milling cutters, and n is the rotational speed of the spindles, okay. This is the formula is the most important use. Milling power estimations, milling power pm equal to in house power, the power is value for the house power is cutting tools is used in the operations, okay. The power is required for the formula is kp qcw hp, okay. This is the formula used for the pm is the milling power in house in HP, okay, and KP the power constant as given in the table. Some of the standard value of the depend on the constant of the value of powers, okay. Plain carbon steels, okay. Some of alloy used for the sum of the material. C is the feed factor given in the tables, okay. Sum all the values for all the standard values in given for the tables, and depend upon the different materials and different values, all the values in variations, okay. And but the sum of the this formula used for the sum of cases for apply the formula, okay, putting for all the values in this formula and find out the value of power, okay. And this is the very importance of the formula, and some of the I discuss for the against for some of the in tables, okay. There are the plain carbon steels. This is the very this is the materials used in the materials were performed to the milling operation, and hardness number bhn number is the variation for 100 to the 240. Okay, 240. All the step by step or variation of the Brent hardened numbers. Okay, this Brent hardened number is increase, and the material strength also increase, and the use for the power cost power is also for increased rate. Okay, suppose that the this material for the Brill hardened number is the 100 to 120. Okay, and the power required for the 1.8 1.80 horsepower. Okay, and second is the increase for the Brent hardened numbers. Okay, and the Brent hardened number increase for the materials, and the material strength is also increased. The material strength is increased, the power milling operation in required for the power is also increased. Okay, and other this is the power is increase. Okay, and the second the alloy steels, this is alloy steel, and the use for the Brent hardened number, it depend upon the 182 20 200 and 200 to 220 and 220 to 240. Okay, and this is the value is for the of the required for these operations, and estimate the value of the uh, alloy steels, and this also for use for the power is constants for this the different materials, and the depend on strength of the materials, and the increase for Brent hardened numbers, and required for the power power is also for very high. Okay, and the sum of other parameters is given for the tables, and find the value of the directly put the value of the in a formula and find the value. And this is the also for some of the other value in standard values given for the Indian ISO for Indian administratives of the standard organizations of Indian standard organizations, and other for other the countries use for the sum of standard values on this operations. Okay, milling operations for the feed rate and tooth feed per teeth. Okay, for the also for the 0.02 say 0.20. Okay, the feed rate is also for the increase, and feed factors. Okay, feed factor is also for 1.70 to 1.40, 1.30, 1.125, 1.20, 1.15, 1.66, 1.11, and 1.00. Okay, in the feed rate is the feed rate is decrease, and the feed factor is increase. Okay, feed factor is increase, but the also for other materials feed rate is the also increase, and the feed factor is the decrease. Okay, feed factor is decrease. The feed rate is per teeth is the decrease, and the feed factor is increase. Okay, some of the special operations used for the specials of the materials, slab milling and end milling operations for tool wear factors is 1.10. Okay, is the slab milling and end milling in use for the tools wear factors is the 1.10, and light and medium face milling is the value of the feed factor is varies from 1.10 to 1.25. Okay, and heavy face milling operation is the tool wear factors is for increase for the value 1.30 to 1.60. Okay, 1.60 mm. All the values is the very importance of the this tables. Okay, this is values are not given for the numerical problems, and this value is directly put for the in questions and solve this problems and analysis. Okay, this is the you for the learn for the very deep in this this tables. Okay, I solve these problems is the very helpful provided to. Okay, and this is the video is very important for the dear students. Subscribe this channels and watching this video. Thank you so much.